Welcome to the second video of factoring trinomials. I ended the last video where I just went through the notes and then I just said, okay, go ahead and try the practice. I've decided to make a note or a video with the practice questions that I had assigned. I know there's some worksheets as well that are attached, but these are the practice ones that kind of came with the notes. So I'm going to go through them just because there's similar ones, but there's some different ones, and I think everyone just needs to see a few more examples here, okay? All right, so again, I have a couple different columns here. I have the simple trinomials. That just means that the number in front of the x squared, m squared term, okay, is 1. Okay, so there's just no number there, so that just means there's a 1 there. And I have the complex column as well, where there is a number that isn't 1 there. Okay, so 6, 4, etc. Okay, so the reason why I have this pointed out is that if you wanted to use that little trick method where you just use the product sum table and boom, go right to your answer, you can do that in this column here, but here don't be doing that over there, okay? All right, so let's start these from scratch. So I'll just erase this out of here. Okay. So let's start with the first one, A. M squared, subtract m minus 12. So again, the first step that you need to do when you're going through these questions is always check to see if there is a greatest common factor that you can divide out, okay? So there's number 1, there's number 1 here, a negative 1 here, and a 12 here. So all three of those together, the greatest common factor is 1, okay? So, you can write that down just to remind yourself, okay, I did that step. All right, so since there's nothing to divide out, we're just going to go to the next step, which is the sum and product table. So let's do a different color here. So we have the sum of the middle term, which is the b, that's negative 1, and the product of negative 12. Okay, so again, you need to remember that in general, the trinomial has this form. Okay, so a squared is that first one. So you're taking so if I just write this again, just a reminder, you're taking the sum for the value that's b, okay, and the product is when you take a times c together, okay? All right, so again, b here is the value negative 1, and then a times c for this one is negative 12. Okay, so you're trying to think of all of the factors until you find the factors that you need. Okay, so when in doubt, so if you're just kind of tired one day, you don't know, you can't think of the two numbers that will work here, go through all of them. Okay, so your goal here is so I'm going to start finding the products first, is that you need to have negative 12, not just positive 12, but negative 12. So you're trying to think of all the numbers here. So, 1 times 12, okay, that works. Okay, don't know what's highlighting here. And then you want to have negative 12. So if I make this one here negative and that one positive, then that's what you're going to get. Oh, there we go. Okay, and then so that will make negative 12, but then will it add to make a negative 1, which is the sum? No. Okay, so, if you wanted to, list off the other possibility, you can, but you know that these numbers tweaked, added together, will never make negative 1. It's not even near negative 1. Okay, so we'll go to the next one. So you're thinking 2 and 6. Okay, so right now the possible values would be like this one, or positive 2 and negative 6. But again, if you just think of the numbers 2 and 6, if I add or subtract them, are they going to end up with a value of 1? No, so not my two numbers that I need. All right, let's go to 3 and 4. So again, I can make this one negative, that one positive, or this one positive and the other one negative, because in the end, our goal here is to multiply to negative 12, and so that will work, but then you're looking and seeing if they'll add up to a 1, okay, or -1. So if you look at the first pair, -3 and 4, so if you were to add those over here, so if you are to add those, okay, that's not going to make -1, okay, so that's no. But if you take the other ones, 3 plus -4, yes, that will work. Okay, that's going to get you to what you need. So those are the numbers, the pair numbers that you need there. Okay, so right there. Okay, so just to kind of get through these a little faster, I recommend that, like, so just ignore this part here. I recommend that if you had to find the sum of -1 and the product of -12, what I'm doing as I'm going through, so you're not taking the time to write all the negatives in when you don't really need to do it. I just kind of go 1 times 2, okay? If I, so I know those will multiply to make 12, but if I were to add or subtract them, will they even get near the number 1? No, okay? So then I think 2 and 6, okay? So 2 and 6 will multiply to 12. Right now I'm not worried about the negative signs here. I'm just quickly checking 2 plus 6 or 2 minus 6. Will those go to a value of 1? No. Okay, so then I go to 3 times 4. And then same thing, they'll multiply to 12. I just have to tweak the sign. But if I were to add 3 plus 4, will that make 1? No. But if I subtract them, yes, you can get to value 1. So this is how you know, okay, I'm in the ballpark here. It's got to be something to do with these two numbers. So then I'll go and find, okay, the possible values are, well, I can make that negative, or I can leave 3 positive and make 4 negative, and that's how you know, oh, it's okay, I'm in the ballpark, it's one of these, and then you get to your answer. So instead of doing what I did here where I listed off every single possibility, because it takes time, you can do it quickly where you're just kind of thinking of the two numbers. If I add or subtract them, right, can I get to 1, like the value of 1? No, no, yes, I can. So now I just got to adjust the sign. So no for this one, no for this one, but when I adjust the sign for this one, yes, I can get to my goal, which is -1. Okay. All right. So I'm going to be doing that. If that didn't make sense, I'll do that again, all the way through here, and hopefully you can use that strategy as well. All right. So we know that 3 and 4 work. So we will. Here, I'm just going to give us some more space here. Okay, and add it down here. Okay, just because I think it was a little messy the first time I did this note here. So this was our question. We needed to factor it out. We found that these two numbers work. So we're going to use our decomposition method. So it's plus 3m minus 3m subtract 12. Okay, and then from there, you were thinking, okay, I can, what can I divide out of the first two together? Okay, no numbers work, but they could both divide out an m. And then the next two, what can they both divide out? Okay, and then again, take a look, this first one here, okay, of the pair, because it's negative, you know you got to divide a negative out. Okay, so negative, and what number works for both? 4, so -4 will divide out. All right, and then keep going here and divide, or factor those out. So you get m comes out, and then that leaves an m plus 3, and then a -4 comes out, and that leaves m plus 3. Okay, and as you're going through, when you get to this step here, if these are not looking the same, something went wrong, so go back and double check your work. Okay, and then from here, you guys know that you can divide these out, but hopefully at this step here, you're like, oh yeah, I could just throw that out, and then whatever is, I could throw these two, right, or throw it out, and then that leaves me these two left. Okay, but anyway, I'll just write all the steps first for this one. Okay, so you know these are the common factors now. And then you get 2, okay, the common factor comes out, And then what was left was the m minus 4, and it gets its own bracket. Okay, all right, so that's how you need to go through with decomposition. And for the people that wanted to use the trig method, you knew that this was an a equals 1 type trinomial, a simple trinomial, so you knew that when you got to your product sum values here, you can jump right to the answer. So this is positive 3, so m plus 3. This is negative 4, so m minus 4. Okay, and we're going to try 2 here. I'm just going to clean it up so that just get this other stuff out of here. All right, so you can start working ahead of me and just thinking, okay, step 1, remember? So even if you have to kind of write it out, you know, remember to remind yourself, step 1, look for the GCF. Step 2, okay, you know, find the product sum table. Step 3, that's this part down here. Okay, go through the decomposition method. Okay, so step 1, GCF. Is there a number that I can divide out of all of those terms? No. Any letters? No. The only thing that would work is a 1, so I'm good there. I made that step's done. Okay, step 2, let's do the product sum table. Okay, so we need the sum of the middle term, which is 1, and the product of the outer terms, okay, which is 90. Okay, so from there, you have to brainstorm and think of the conditions are you have to multiply to negative 90, and you have to add to positive 1. Okay, so let's try to use that trick I was trying to show you in the last example, where you're just trying to brainstorm as quickly as you can all the different factors that make up 90, and then but as you're going through, kind of add and subtract them and see if you can get to a value of 1. Okay, and then when you know you can get to a value of 1, it's about tweaking it so the signs will work. All right, so again, if you can't think of the two numbers right away off the top of your head, just list them all off. Okay, so again, I'm just going to write the numbers with the signs. Okay, so 1 times 90. Can I add or subtract those to get to 1? No. Okay, so then let's try 2. Does 2 work? Yep, 2 times 45 will make 90. Again, don't worry about the sign yet. Can I add or subtract those to get 1? No. Okay, so here, we just keep saying no. Keep writing, no, no. Okay, 3. 3 times 90, or sorry, 3 times 30 makes 90. All right, same thing. Can I add or subtract those to get to 1? No. Okay, all right. So then see if 4 will go in. It doesn't go in nicely, so 5 times 18 will make 90. Can I add or subtract those to make 1? No. All right, keep going. Okay, 6. So again, I'm just kind of going through all the factors. Like 4 didn't work, it came out to 22.5. So 6 works though. 6 times 15 will make 90. Again, can I add or subtract those and get a 1? No. Okay, so keep going. 7 doesn't work. 8, nope. 9. Okay, you know that 9 times 10 will make 90. Okay, but if I add or subtract 9 and 10, can you get a 1? Well, if you add them, you get 19, but if you subtract them, yes, you can get a 1. So we found the numbers. Okay, now we just have to figure out what sign that they will have. Okay, so our first condition here is that you need a product of negative 90. So that means one of these has to be a negative sign. Okay, so let's write out the possible answers. So we have negative 9 and positive 10, or we can have positive 9 and negative 10. Okay, so now from there, if you add them, the first pair, okay, if you add the first pair, will you get, so I can do that here. If I add them, will I get a positive 1? Yes. Okay, so we found our pair. Okay, if you wanted to just check this one, oops, yeah, well, yeah, add negative, you're going to get a -1. So this one is a no. Okay, so we found our pair that we need, and that's what we're going to use for our decomposition step that's coming up next here. Okay, all right, so that's key. You have to grab the right negative and positive values because then it's not going to work, okay? All right, so let's start, write out the question here again. X squared plus x minus 15, okay? So that equals, so you're going to decompose the middle term. So this plus 1x is going to become 9x plus 10x minus 15. Okay, so again, you're taking the numbers that you just found from your table, putting them in here with the x. Okay, so that becomes -9 and positive 10. So again, the sign is important. Please don't just kind of grab a 9 and 10 and throw it in and hope that it'll work. Okay, all right, and then from there, we are going to factor by grouping. So just pair them up. And so these two, okay, what number works for both? 6 and 9, I can divide a 3 at the biggest number is 3. Okay, on top of it, an x can be divided out of both of them. So the greatest common factor there is 3x. Try the other one. So here, I'm always checking that the next pair, the first one is if it's positive, make sure then you can just divide it positive. But remember here, it was negative, the first one of the next pair. So make sure to divide out that negative, okay? Because otherwise when you get to this step, then the sign won't be the same. The number might be the same, but the sign won't be the same. And that's important. It has to look exactly the same. All right, so this one here. All right, 10 and 15, brainstorm, brainstorm, brainstorm. 5 works, right? And they both don't have a letter, so no letter can be divided out. All right, and then go to here. Okay, write the greatest common factor out first. Okay, and then divide through 2x is left, and then here just a 3 is left, bracket, plus there's a positive 5 greatest common factor, and then we have 2x and 3. Okay, all right, so again, you are checking this step here that these two are the same, okay? And then hopefully you're seeing here, when you get to this step, like in the previous question, you see that these two are the exact same. So it's almost like you take it, you throw it out, put it in front, and then you leave what's left. These two are left behind. So hopefully I can just do this step right now and not confuse anybody. So I'm looking here. I notice that these two are the common factor, okay? So I'm going to write that common factor outside, and you need to write it in brackets, don't forget. And then what's left? Well, here, I'll even underline it. I'll underline yellow. So these two are left. Okay, so once I take out that common factor, do you see those two are left? That's what you write in the other bracket. 3x plus 5. Okay. Okay, on to the next one. B. B? Yeah, B for both of them. Okay, there's A, B. Okay, so again, if you get the trick method, you can go ahead and, just once you find your product sum values, you can just go right to the answer. I'm just going to maybe I'll do that for here so that you guys can see that one. Okay. But yeah, anyway, step 1 though, always check before you do this to find the greatest common factor. Okay. So 1, -9 and 18, and they don't all have an x, so greatest common factor is 1. Okay, so I don't need to do anything there. Case 2, go to your product sum table. So the sum of -9 and the product of AC, which is positive 18. Okay, all right, so again, brainstorm. Hopefully, if you can think of the two numbers right away, like you're thinking, okay, what times what makes 18, but we'll add to make 9. And if you thought of 3 and 6 right away, awesome, okay? And then from there, hopefully you see that you have to tweak the signs though. But again, you're a little tired, can't think of the right numbers, just list them off. Go 1 times 2, okay? If I add or subtract those, could I make a 9? No. All right, 2 times 9. If I add or subtract those, no. Okay, because that would become 7 if you subtracted them, or if you added them, 11. Nope, that doesn't work. All right, what about 3 and 6? That multiplies to 18. Oh, but yes, you could add them and make a 9. So we know we're in the ballpark here. So now our condition is it has to be positive 18, so that would work. But we have to add to negative 9. So right now, 3 plus 6 will not make 9. So you're thinking, what are the other possibilities? Well, play around with the signs. Oh, I can make them both negative, okay? And that will still make positive 18, but I will also add to negative 9. So this is the one I want, okay? Okay, so not positive 3 and positive 6, negative 3 and negative 6. So because it's a simple trinomial, you know you can use the trick that as soon as you find the values from the product sum table, you can jump right to the answer. The answers are right there. Okay, so again, the x squared minus 9x plus 18 is, well, you always write the x, right? And then you just take the first one, which is negative 3, bracket, and then write x, and then write the other one, negative 6, and you're done. Okay, you don't have to go through the decomposition method. So if you can just memorize this step, it's really good. So if you know you have a simple trinomial, so that just means a is equal to 1. There's a is equal to 1. There's a 1 here. Okay, so then as soon as you find your factors from the product sum table, you can jump and go, oh, those are the 2 factors. So just put them into this form here, and you're done. Okay, but again, cannot use this for the one on the right here because a is not equal to 1. Okay, so it's more complex. So you need to go through the steps of decomposition here. Okay, so step 1 though, before you get there, greatest common factor. Is there a number I can divide out of all of those? 4, 12, 9, nope. Okay, x, nope. Okay, so just get in the habit, just do that step because there are some below, some in your checkpoint as well, where there you have to take some number out. Otherwise, you'll be sitting there for a while going, none of my product sum numbers, like there are no numbers that work here. So is it I cannot be factored or can it actually be factored? Okay, so just, yeah, do the step first. Otherwise, be a lot of kind of checking things over and then you're not sure what's going on and it's going to eat up a lot of time. Okay, so and get you to the wrong answer as well. So, all right, so I checked my GCF. We're good. There wasn't one that I can divide out. So again, remember the sum is B, so that's the middle one, and then product is the product, multiply the first and the second, or first and the last term. So 4 times 9 is 36. Okay, 1 and 36. Okay, so again, can I add them to make a 12? No, because that makes 37. If I subtract them, it makes 35. So no, these are not the numbers. How about 2 and 18? Are they going to make a 12? No. Okay, so again, you're just trying to add and subtract, trying to find the ballpark numbers here. What else? 3 times 12 makes 36. Can I tweak those and make 12? Nope. Okay, I'll add to 15, or if I subtract them, I get a 9. Nope. All right, so what about 4? 4 times 9 works to make 36, but no, I can't make 12. So 5 doesn't work. 6? Oh, wait, yes. 6 times 6 makes 36. 6 plus 6 can be tweaked to make a 12. All right, we found our numbers. Now we just got to tweak the sign. So 6 times 6 does make 36, but it will not make negative 12. So what are the other possibilities? I need to make positive 36. I can do that with a negative 6. Negative 6 And if I add those, I will make negative 12. So I found my two numbers here. Okay, so again, if you are getting really comfortable using that trick method that we did over on this side, don't use it here, okay? You can't just dump now 6 and 6 and make them the factor. So you got to learn to turn off little trick methods here and there, okay? So again, you can use it on simple trinomials. Don't use it on the complex ones, okay? So you have to go through the decomposition method. So just a rule of thumb here. All right, so here we go. Write this one out again so we have it close by. All right, decomposition method. Write the first one out. We're going to decompose that middle term to -6 and -6 plus 9. Okay, so if we were to add them, they would go back to negative 12. All right, so from there, you need to find the common denominator, or greatest common factor. So, and pair them up. Okay, so we have 4 and 6. What works here? Well, they can both divide out of 2 and also an x. Okay, and the next one. And again, if you're to the point where you don't have to show this work, you can just go right to the factoring step if you can, okay? All right, here I'm thinking, all right, a 6 and a 9 do have something in common, but on top of it, that first one of the next pair, right? This is the next pair here. The first one is a negative, so you got, remember, you got to divide a negative out. Okay, so what negative? A 3 works for both. They don't both have a letter, so there, no letter will come out. Okay, and go through and factor out the greatest common factor here. Okay, and then you know you're on the right track if you are getting the same factors coming out. Okay, and remember they have to be the exact same. It can't be a plus on this one and a subtract on that one. That means something went wrong with your sign. So, all right, and then next step, hopefully again I can use that trick. Do you see that they have both of these in common? Okay, so that can be removed out. And then I know it's a little weird, but and you're like, well, the same thing is left behind. Yep, that's fine. That happens sometimes. Okay. All right, so I'm going to factor out the, so I'll even write it in orange. I'll factor out this one that I underline in orange. And then what was left behind was this one in yellow. And yes, they are the same. That happens sometimes. Okay, but again, hopefully you see that if you tried to use that trick method up here and put 6 and 6 in, you would have gotten the wrong answer. This is what the answer should be. And just to clean it up, you want to write it simplified and say, oh, I got the same answers, so I could just write it like that, squared. Okay, let's move to the next one. Okay, so moving on to C now. Again, this is a simple trinomial. Okay, a is equal to 1, so I can use that trick method. This one here is a complex one. Don't use the trick. All right, so we'll start off with step 1. Is there a greatest common factor? No, just the 1. All right, step 2. I need the sum of the B term, which is the middle one. It's a positive 1. And I need the product of the A and C terms. That's negative 52. Okay, so again, you don't always multiply up to 52. So if you can't think of the factors, that's okay. Start from scratch. Okay, so again, use the little trick that I've been showing you today. 1 times 52 will not add or subtract to 52. Okay, so then you what I do is just go 52 divided by 2. Yep, those two would work. It's a 2 and a 26 that would work here. Again, not going to tweak and add to 1 or subtract to 1. All right, let's see if 3 works. 52 divided by 3. Nope, get a decimal. 52 divided by 4. Okay, that one's nice. It works. 14 times 13. Can I tweak those and add to 1? No. All right, 52 and 5. No. 52 divided by 6. Nope. 52 divided by 7. Nope. And so forth. I'm just kind of going through here. 9 divided by 10. No. 11. No. 12. No. 13. Okay, and then like so as you go through, and the next one I would have gotten to is, so because I tried 4, 5, 6, 7, 8, 9, right? And then I would have I've come back to 13. Like 13 can divide out of 52 and get 4, but hey, I already have that pair of numbers. With 1 times 52, no. 2 times 26, 3 came out to a decimal. 4 worked. Okay, 5, 6, 7, 8, 9, 10, 11, 12. All of those, if I divide them out, comes out to a decimal. But then I'm back to 13. Okay, so if once you kind of come back and you start hitting the same numbers, that's where you stop and go, okay, I've thought of all the factors. And so now if you're analyzing the 3 that you found, the 3 pairs, you found every single one because you went through the whole list. And again, you went through the whole list because you went 5, 6, 7, 8, 9, 10, 11, 12, and you're back to 13 again, so you hit everything. And so now, and you've checked, I cannot add or subtract any of these pairs to make a 1. So I know I've checked everything that I can possibly check, and I know I did it correctly. So there are no factors that work here. Okay, to give me my product sum, so I can't find the sum of 1. So, and that happens sometimes. All we do for now is we just write cannot be factored. Okay, and so basically that's what you do for now in the cycle. When you first start off, we're just trying to find nice integers or whole numbers, positive, negative numbers that will work and be factored out. If we can't find those nice numbers, then we just stop and write cannot be factored. And I should literally write for now, okay? Because you will find that I'm going to teach you some more tools and tricks as we progress into the other units. And you'll find that there are other methods that we can use, and there are factors that work, but they end up being decimal answers. Okay? All right. So, again, don't just write cannot be factored for anything just because you get stuck. Make sure you go through all of the steps. Find the greatest common factor, look at the product sum table, look at every single factor that can possibly multiply to the number that you need. And if you cannot add to the number that you need, then you know, okay, I've checked everything. This is a cannot be factored answer. Okay? All right. All right, so let's go to the next one. So this is the complex one. Okay, step 1, look for the greatest common factor. Okay, 3, 8, and 4. Nope, just a 1 works there, so move on. All right, the sum of 8 and the product of 12. Okay, so again, let's go through the possible factors, but hey, if you think of one right away, okay, good job. Go right to it and figure out what signs they should have, and then I'll go from there. All right, so 1 times 12. No, I cannot add or subtract those to make 8. All right, well then fine, I'll try 2. 2, does that work? Yep, 2 times 6. Can I add those to make 8? Yes, I can. All right, so let's double check everything. So I have a positive 2 and a positive 6 will multiply to make positive 12. Positive 2 plus positive 6, will that make 8? Yes, I have my 2 numbers, okay? So you don't need to keep going and finding all the other ones unless you just like, this is fun for you and you want to do it, you can. Here, let's just keep going then. Just in case. So if you were, like you found the 2 numbers, but if you wanted to go to 3 now, 3 times 4. All right, that makes 12, but that will not make 8. And then the next number that you have to grab is 4. But see how you come around? Oh, you already found that pair. So now you can stop. You know you found all the factors for 12. Okay, all right, but in the end, you didn't have to go that far. But if it was fun, go for it. Okay, here we go. Those are the two numbers that work. Okay, so from there, you have to use the decomposition method now. Okay, so remember, do not use the trig method that is on, that we did above here. Okay, where it's like, oh, I found the factors, boom, I go right to my answer. You cannot do that with the complex ones, okay? All right, so go through the steps and do decomposition. So I'm just gonna write it out again. Okay, so I need to factor this, okay? So remember, that's the key word, get comfortable with it, factor. Okay, so to do that, you're going to decompose the middle term with the two new values that you found from your product sum table. Okay, and then factor in pairs, factor in groups. Okay, so I'm going into this one and this one. Okay, any numbers that work? 1 does. But any letters? X does. Okay, so I don't write 1 because I know I could just write X. But if if it really bothers you, you can write 1X, I guess. And then from there, the other one. What works with these two? Okay, they're both even, so 2. Any letters? No. Okay, so from there, an X will come out, and then that leaves a 3X behind, and a 2 here. This 2 comes out, and then 3X plus 2. Again, you're checking to see those factors are the same, and you're on the right track. And then pull out that common factor. And then what's left? X plus 2. Okay. All right, so let's go move to the next one. Okay, so again, do not look at these answers and go, oh, I got to multiply now. I have to use FOIL, okay? Remember, you're factoring. FOIL, that method is for when you're asked to expand it, okay? So just stop here. That's your answer. Okay, let's move to the D's. Okay, so again, you have a simple one here. You don't have a simple one here. Okay, A is 10, A is 1 here. All right, step 1, GCF. Okay, I know you're thinking, okay, why do I have to keep doing this step? There's never a greatest common factor. There's one coming up, okay? Just be ready for it. All right, so step 2. The sum is 6. The product is A times C, 9. Okay, and right away, if you can think of the two numbers, that's what I want you to be able to do, okay? That means you're getting faster. But if you don't think of them, that's okay. Just list them all off. Okay, 1 times 9 works to make 9, but I can't add them to make 6. No. All right, does 2 work? No, 2 doesn't multiply by anything to make 9. 3? Yep, 3 works. And then see how 3 is multiplied by 3? So that's how you know, like, you've come back to all the other possible factors, like 4 won't work, and so forth, okay? So as soon as, yeah, like it's like the numbers, just they have to multiply to 9. So this does work, and we're just checking, does positive 3 make positive 6? Yes, it does. All right, again, this is the simple trinomial, so you can use the trig method. That means, oh, my answers are right there, so I can simply write, okay, the factored form is a positive x plus 3 and another x plus 3, and you're done. And whoops, go one more step and just simplify it. Right, squared. All right. Okay, so on to the right side where we have the complex one. Step 1, GCF. Is there a number that would work here? Okay, so you're looking and you haven't seen one yet, but look, yes, these are all even numbers. So what number can divide out of all of them? Well, let's hear. A 2 would work. 3 won't work for most of them. Okay, 4. So what you do here when you're trying to find the greatest common factor is kind of count up as well. So like you're thinking, okay, 1, yes, works for everything. 2 works for all of them. 3 works for the 36, but not for the 16 and 10. So definitely not 3. All right, so then you're like, okay, 4. Does 4 work for all of them? It works for the last two, 36 and 16, but not for 10, so not a greatest common factor. How about 5? Okay, no, 5 doesn't work for any of those. 6 works for 36, okay, but not the other two. So again, back when we had 5 works for 10, but not for the other two. Okay, so 6 doesn't work. How about 7? No. 8? No. 9? 9 works for 36, but not for the other two. Then you're like 10, okay? 10 works for 10, but nothing else. But so once you get through all the numbers and you get to the lowest number, which is 10, through all the factors, and nothing worked. Okay, so nothing worked. So the greatest one that worked was 2. Okay, so we know that the greatest common factor is 2. All right, can they all divide out a letter? No. All right, so let's do that step now. We haven't had to do it so far. Here's the first time we're seeing it in the practice. All right, but this is what you did when you were doing common factoring in that lesson way back back in the other unit. Okay, so we're taking the common factor, we write it here, and we're going to write 5x squared, 18x, and 8. Okay, so we took out a greatest common factor. Now we can do the product sum. But when we do the product sum, we're going to do it for this part right here. Okay, that 2 will stay outside and it'll be written in our final answer. But for now, we are tackling the product sum in here. So we're going to take the sum of the 18 and the product of negative 40, which is the A times C, okay? And then the B is right there. So that's key here. And so if we do that, everything else, so just kind of to start off that question was a little bit different from the rest, but everything else is the same. All right, so think, what makes 40? 1 times 40. All right, will that make 18? No. 2 times 20, okay? So you're thinking when I add them, it makes 22, but when I subtract them, it could make 18. So we found the numbers we need, okay? We just have to tweak the sign. So right now we need to multiply to negative 40, and we have, so to get a negative number, one of these has to be negative. Okay, so let's, again, if you're a little tired, you can't think of it in your head, list off the possibilities here. Okay, so I can make the first one 2 negative. So if I multiply those, I'll get negative 40. If I add them, will I get positive 18? Yes. Okay. So if you try to add the other two, no, that's going to make negative 18. So we don't need those two numbers. We need these two. So the 2 has to be negative and the 20 has to be positive. Okay. All right. So what do we do from here? All right, we have to use decomposition. Again, don't use the trick. This is a complex trinomial. All right, in order to do that, so we just got to bring this question down. So this 2 is still sitting outside. I'm going to use some square brackets to leave it out there because we're going to have some more brackets inside. So for now, we can just write. Okay, so maybe I should have just used square brackets right at the beginning here too. Okay, all right, so our decomposition method says, okay, take that middle number 18 and break it into the 2 numbers that we just found. Okay, so negative 2 and positive 20. All right, and then go through what you did before, find factor in groups here. Okay, so 5 and 2, no numbers work, but they both can divide out an x. And here, 20 and 8. Okay, so you're thinking, what works for both of those? What's the greatest number that works for both of those? It is even, so 2 would work. 3, 4 would work. Anything bigger than 4? No. Can they both give me a letter? No, so 4 is the greatest. Okay, so from there, I think I'm going to keep these the same colors. You can kind of follow along. So this 2 is still that 2 from before. All right, so we're factoring out an x here. So we'll put x here. And then what's left? The 5x is left. And then the next one, just the 2 is left. Okay, and the second pair we're factoring here, the 4 came out. That left 5x, and subtract 2, and our square bracket. Oops, wrong color. Square bracket. So, looking like what we had before, just this extra square bracket around it. Just keep carrying it along. All right, so what do we do next? I don't know, I can make it a different blue here, I guess. Okay, so sorry, this 2 is still hanging out here. Keep writing it, don't forget about it. All right, so now inside of the square brackets, we are now taking out the common factor of 5x minus 2, okay, and that leaves x plus 4 when we factor that out. Okay, and then now we're done. Okay, so we can rewrite it without all these extra brackets, because this is now saying it is 2 times 5x minus 2 times x plus 4. So I can simply just write it without the square brackets like that. And that's my final answer. Okay, so that's it's an extra step compared to what we've been looking at, but it's important to take out that greatest common factor. So it's kind of the combination of the common factoring lesson and this new lesson of factoring trinomials. So again, if I were to mark this, I want to see that 2 there. I want to see this binomial perfectly like that and like this. So it would be out of 3. Okay, and the one over on this side here, I would have given you a mark like so. 2 marks here, okay? So to get x plus 3 and know that there's another x plus 3, give you the marks there. Okay, so here, you know, if you put this and this here, I'll give you the mark. But I want you to simplify it to look like x plus c squared like that, because that's a more cleaned up answer. Okay, and I'll give you 2 marks for that. Again, so I'm hoping that you are getting more comfortable with these now. Yeah, you can kind of go through the steps. Remember what to do first, second, and third. Okay. All right. So again, always check. Oh yeah, this is a simple one. Okay, this is a complex one. So simple one, you can use a trick. Okay, complex ones don't do that. We're looking at w squared now. So step 1, is there a greatest common factor that you can divide out? No, just a 1. Okay, so next step, the sum of negative 12 and the product of 36. Okay, so from there, if you can think of the 2 numbers right away, like what times what makes 36, but would add to make 12, hopefully you can think of the 2 numbers. But if not, this is something you can fall back on. 1 and 36, no, they can't add or subtract to 12. 2 and 18, no. 3 and 12, no. 4 and 9, close, but still no, it doesn't add to 12. 5 does not divide into 36. 6 does. 6 times 6. Okay, so we thought of all the factors here. So this one works because if I add them, oh, no, it doesn't work, sorry. All right, so I'm trying to get to positive 36, but if I add them, it will not add to negative 12. So the other possibility is the negative and negative. We'll make positive 36, and negative 6 plus negative 6 will add to negative 12. So we're good. Those are the 2 numbers. From there, this is a simple trinomial, so go ahead and use the trick. Okay, save yourself time. Decomposition has a lot of steps in it. Okay, so in the end, you can say, oh, it's not an x, it's a w. W minus 6. W minus 6. Okay, so there you go, 2 marks. But let's clean it up. Okay, write it squared. Okay. All right, on to the next one. Step 1. All right, a is not equal to 1, so remember, don't use the trig method here. Check for a greatest common factor. Okay, and hopefully you're seeing, oh, I can divide a 3 out of all those numbers. And since 3 is the lowest number there, I can't go any higher. Like I can't try 4 or 5 or 6 because then it's higher than the lowest value there of 3. Okay, so since I have a greatest common factor, let's divide that out. I have to do this extra step with this question, but then the rest of it is still the same. Okay, so this 3 comes out, and I put square brackets, m squared plus m minus 6. Okay, all right, step 2. So again, you are now taking the product sum of just this part. Okay, not the original question, just that part. So we have the sum of 1 and the product of negative 6. Okay, so from there, think of all the numbers that can multiply to 6. Okay, don't worry about the signs right now. All right, 1 times 6 will make 6, will not make 1. Okay, 2. 2 times 3. Yes, I could tweak that to make it 1. Okay, and if you're thinking of some other factors, 3 times 2, you're back to 3 now, so you thought of all the factors. Okay, so I need a negative 6 here, so that means one of these has to be negative. Okay, so let's try both of them. But again, if you can think of this in your head, that's what I'd rather that you do. So just practice until you get to that point. All right, so those are the two possibilities. Those will both multiply to make negative 6, but which ones will add to make positive 1? Okay, will it be this one, or will it be this one? Okay, so hopefully you see negative 2 comes in, tries to battle positive 3. The positives, there's more on their team, so they will win. Positive 1. This is the one that's going to work. This is not happening, okay? Again, so you're like, okay, I found the two numbers, and then you are tempted to use that trig method. Don't use it, okay? It's complex, doesn't work in this case here. So go to the decomposition method here. Break apart that middle term using your two new values that you found. Sorry, it's 2m. All right, and then from there, find your factors. All right, my two factors there came out the same, so I know I'm on the right track here. All right, and then you're getting to here. Take out the common factor that you see. This one's left behind. Oops. And then you don't need your square brackets. Okay, so again, if you don't need something, don't write it in. And there it is. There's your final factored answer. Okay, so that's one thing I didn't show in the other videos. So I wanted to come back to it, and then I wanted you to kind of get more efficient at finding those factors in the product sum table. So that's why I wanted to make the second video. Okay, all right, so do we have any left? Nope, that's it. Okay, so those are all the different ones in your practice, and I think that should have shown you everything that that's out there. So again, always be checking for the GCF because there might be a number that can be divided out, and if you don't do it, it ends up messing with you with the product sum, and you're sitting there and you're trying to find the factor and it doesn't work, or sometimes it does work but you don't end up with the most factored answer. Like for example here, if you didn't find the GCF, you may have gotten an answer like 3m minus 6 equals m plus 3. So basically the second one here is factored nicely, but this one here you can actually still divide out a 3 out of both, so it's not considered to be as factored as possible, so you don't get the full marks. Okay, so this is no, oh, goodness, it's not as factored as far as you can. Okay, so that's why don't do this here. Okay, don't do that. All right, so just make sure, find that greatest common factor that fixes the problem. All right, and then yeah, like you use the square brackets because then you're going to make more brackets inside here. So that's why you use the square brackets to differentiate them from the inner brackets. And watch out for these ones too. There won't be too many on assessments, but just watch out for these ones. If you know you've looked at every possible factor that can multiply to the product and nothing works to sum up to this number here, then you write cannot be factored, okay? But if you're writing, like say if there's 10 questions and you're writing it like 5 or 6 times, cannot be factored, you're doing it incorrectly. Like if anything, I'll put maybe 2 out of 10 at the most that can't be factored on an assessment, okay? All right, and so yeah, like if you have any questions, just email me. Let me know if you want some more examples and so forth, okay? But hopefully you feel pretty confident with doing these, okay?